G'day guys, welcome back. Today we have got a 2000 model Toyota Prado 3.4 litre. It's coming on a tow truck, running very poorly. So the backstory is that this car was driving and then it stopped, had a timing belt kit fitted for some reason, running like crap still. They had an auto electrician out, the engine light was on, still running rough. So I'm just going to get the scan tool. We'll plug the scanner in, whichever one we choose, and then we'll see what we come up with and decide what we need to do from there. Alright, we got the X431 connected. As you can see, codes. Actually, don't worry about the top two codes because I just had a look under the bonnet and they were actually unplugged. So don't worry about the top two. What we're looking at is P1300 igniter circuit 1, which does make sense because as you can see here, we've got one ignition amplifier and we've got two ignition amplifiers. So I think they've tried to replace them a couple of times and it still hasn't solved the problem. So let's get this thing started and let's go out and have a look. Alright, I'm going to start this up and show you what happens. So it does run, but very poorly. It's missing on one or two, probably two, the way it's running. So first thing we're going to do is a quick relative compression test. What I'll do is I'll take up all this air ducting to access the coils, unplug all the coils quickly, do a relative compression, and we know is it a mechanical fault or not, and then we'll decide what to do from there. Alright, we're set up with the eye tester. It's literally a 2-minute check by the time you open the box. We'll just unplug the coils. Let's hit start and see what happens. See what we get. And look at that, all good. So we know we don't have a compression issue. Let's plug the coils back in, get the GTC 505 out and see if we've got a spark issue. So I'll get that set up and get you back on. Alright, I'm going to try and do this quickly because it's running like crap with the match disconnected. So basically, as you can see here, this number one coil, which our code's referring to, has got no operation at all. So if I go off the lead off it, we've still got no spark off that lead, but if I put it to this lead, we've got a spark waveform, so we've got no spark at all in this coil. So what we can do is, let me just turn this off. So if we've got no spark coming out of that coil at all, we've got a couple of options here. Look, it's really easy to swap the coils between the cylinders, but sometimes when you do that you can, rectify a fault if there's an issue with something with the coil or the connector. So if we can, we're going to try not to do that. What we're going to do is we're just going to quickly grab the scope, portable one, whatever I've got, the U-scope or the VISO, and we'll plug into the connector here and we'll see if we've got control, right? Because if we do have control and we've got no spark, then we know that that coil is faulty 100%. It's going to get a coil, a lead, and two plugs both sides. So we'll get the scope, set that up, and then we'll go from there. Alright, we are connected on the constant battery feed to the coil. As you can see, we have got our 12 volts on the VISO. So what will happen is that I'll put this onto the control side. If we've got integrity of the coil, we'll get 12 volts on this side too because it will feed through the coil. So let me just see if I can do both at the same time. I'll get you on here. And as you can see, the coil is definitely, I'm trying to poke that in there, but we definitely have a feed through the coil. So the coil is definitely not open circuit or anything like that. So what we're going to do is we are going to get this in a position where it's actually going to read properly with me letting it go. There we are. And we're going to crank the car and see if we get a pulse signal to confirm that we're getting control from our computer. So the way this ignition system works is that the computer sends a pulse signal to the ignition amplifier down here, and this amplifier grounds that particular coil when it's commanded by the PCM. So let's crank this, see if we get anything. Alright, that looks like it almost had something for a second, and now there's nothing. That's ugly. Let me put it on a good one. We're on a good one, and we've got control there. Interesting. Alright, let me turn this off. So that's telling us that we are not getting control somehow from either the ignition amplifier or the computer. There's definitely a control issue, so we do not have a faulty coil. Could our coil be causing a control issue? Maybe. What we're going to do to confirm is we need to get a wiring diagram and look at this ignition amplifier to see whether we've got our wiring integrity from this amplifier to the coil, to make sure there's not an issue with any wiring or anything like that. So the way we can do that pretty easily is get the wiring diagram, find out which pin is which, just plug the scope straight onto there and do the same test we did with the key on. So if we've got continuity going through the coil, coming back down here, we should have 12 volts with the key on in this position, and then obviously we'll check the scope again to see if we're getting a signal down here. So I'll set that up, we'll get a wiring diagram and we'll find out which one it is. So we've got our wiring diagram. We know that our ground control to the coil is the blue watt pin number 10. We're just on there, down there now. And with the key on, as you can see, we've got 12 volts. So it's pretty unlikely we've got a wiring fault. What we're going to do is we're just going to crank it, see if we get pulse in here. And same issue. No control. So because our other two are getting controlled, we can probably safely assume there's nothing wrong with this amplifier, and it's already been replaced. It looks like a brand new, genuine Toyota unit. So what we're going to do is we're going to find the PCM wiring, the command from the PCM. We're going to back probe that one and see what we're getting there. Okay, now we are on our computer command. As you can see, we're getting a pulse 5 volt signal. Maybe it's 4 volts actually. This is a good coil, so we know that this one's working. So let's go to the command for the one we know is failing. And we are in there now, and as you can see, we've got no command from the PCM at all. So the next thing we have to do, is go down to the PCM behind the glove box. We just need to make sure there's no broken wire, or are we getting a faulty transistor in the PCM. Let's see what we get and connect up down there, and I'll show you what's going on. Alrighty, we are under the glove box. We're plugged in. We've got our scope tray set up for all 3 coils. I've done this already. I actually just started it up, and I turned the other 2 off just so I can show you what happens with this one. So let me just show you. Let's press start, and then we'll come back. I'll crank it up. Alright, I'll turn that off. Let's see if you can see what I'm talking about. So if we go back a screen to where it just starts, we'll do it again on the other one. Look at that. We have got one command signal, and then it disappears, and then it stalled again, and we started it again, and not that point there. But basically what happens is when you first start the car, it goes to fire, but then it doesn't fire, or it realizes something's wrong, and it loses the command. So for it to be a failing transistor or something internal to the PCM, it's pretty unlikely for it to fire and then stop So I dare say it's not going to be a PCM issue. So obviously we get our inputs from the cam and crank sensor, and other various inputs, but they're mostly based on the crank and cam sensor. So I think the best thing we should do is let's get a cam and crank, either a correlation or get them both up on the screen and see if there's any abnormality there. So I'll get that set up and we'll get you back on there. Okay, now we are on the cam and crank only. We are just on, ready to start the car, so let's go start this baby up. Let me just lean over, I have to do the old reach around to get there. So start this up and see what we get. Alright, that'll be enough. Let's go over and have a little squeeze at what's going on. Alright, so let me just hold this up there. Let's go back a couple of screens. Let's zoom in on one cycle there. Let's just zoom in between this full crank revolution or full cam revolution. Wowee, what do you see here? So for those of you that are familiar with crank and cam sensors, you know that the crank reluctor or the crank position sensor should have a point of reference for TDC. And obviously, as you can see, we've got our point of reference for the cam in the red, and we've got one full revolution of the cam there, and we have two full revolutions of the crank here. So we would expect to see a TDC mark here, TDC mark here, and a TDC mark here to represent two revolutions. As you can see, we've got an extra TDC mark that's not meant to be there. So I'm wondering, when this had the timing belt, is one of the teeth on the reluctor broken, giving false information to the PCM. The PCM doesn't expect the combustion to happen, or the combustion event to happen when it's supposed to, and it stops the command to that coil. I honestly don't know the programming of this PCM, but that makes sense because that extra TDC mark is not meant to be there 100%. So we need to find out why. So I'm just thinking, how easy is the crank position sensor to get to? If I can get the crank position sensor out relatively easily, we'll see if we can get the bore scope in there and turn the crank around, rotate it, and see if we can find if there's something funny going on, a missing tooth or such. Let's just see if I can get that out first to save us stripping it all. So I'll get you over there. Guys, the update is we're pretty under the pump. We had it on the hoist, we quickly took the crank sensor out. We had a quick poke with the bore scope and we saw a bent tooth straight away. Didn't get a chance to record it or anything, so we just spoke to the customer. We're pretty flat out at the moment, so we just pushed it outside. Otherwise I probably would have spun it around properly and saw everything, but clearly with a bent tooth we know something's going on down there. So we spoke to the customer, and the customer actually has just approved to pull it apart and see what's going on. More than likely it's going to be a reluctor issue, so that's what we're going to do. We're going to pull it apart and we'll get you down there. If we can do a video along the way, we will. Otherwise we'll get it off and we'll see what's going on down the bottom, and I'll get you back on. There's our TDC mark right there. Well, we've got our actual TDC mark at the top, but we have a broken tooth there that's giving us a makeshift TDC reference. So that's what's happened. And also we have, if we look over this, we've got a bent tooth right there. So clearly someone has tried to take this off to replace the crank seal when they did the timing belt kit, and these are such tight tolerance that you really need to pull this off. That's why it's got two screws at the front there, or two threaded parts to put some bolts in and pull this off on an even angle to make sure you get this off. It's not it's not a press fit, but it's definitely not easy to get off. So I dare say they didn't try to do that and they tried to pry it off instead, and that's what damage has been caused. So unfortunately that's the case. So new one's going on, and I'm going to get the well, I'll get it running and we'll see if it's fixed, and then we'll get a cam and crank trace and we'll see what it looks like now. The new crank reluctor is on, it's all together, it's running great. There is no engine light on the dash. I can show you that there, no engine light, the code is gone. We're running absolutely sweet. Got the cam and crank trace up right now, so we'll have a look at that. I've just got the trigger on the cam sensor there, but as you can see, if you remember what we were looking at before, we had a couple of extra TDC marks, but as you can see now we've only got our normal TDC mark right there, and I can show you the old capture so you can see what the difference is now that I've got it sort of side by side. As you can see there, that was the broken tooth, so that's the old one. This is the current one currently running. So as you can see, guys, a bit of a tricky one here, but you know, with a little bit of due diligence and some testing, not throwing parts at it, you know, we can get the correct diagnosis done, get the car running for the customer. I'm sure they'll be happy with the amount of time this has been off the road and the parts that have been thrown at it. So yeah, hopefully you enjoyed this one and made a bit of sense to you. And if you did like this, if you haven't subscribed, please do. Thanks for watching, guys.